In lesson 4, we're going to be talking about congruent figures and also congruent triangles. And before, when you had learned earlier, talked earlier about congruent figures, basically you refer to them as being the same, meaning the same shape and the same size. Well, specifically when you talk about congruent figures, I want you to know that the corresponding angles and the corresponding sides are going to be congruent, meaning they're going to have the same measure. And so if I had a triangle here that, let's just say I knew this was a 30-degree angle, and I was given a second triangle, asked about this angle, it would have to measure 30 degrees because it is the corresponding angle. The corresponding angles and the corresponding sides are in the same position in each figure. Taking a look down below, I have given you, or I am showing you, two quadrilaterals that are congruent. So I'm telling you that they are congruent, and we're going to look at their corresponding parts. When I ask you about the corresponding angles, which angle would correspond to angle A? Well, I can see here that because angle A has one arc and angle E has one arc, they would correspond. Therefore, angle A would have to be congruent to angle E. Angle B, with two arcs, would have to be congruent to angle F. They correspond. And we could go through and find each corresponding angle pair. Likewise, we could talk about the corresponding sides. When I want to know about the side that corresponds with side AB, I look over here and side AB, well, it's between the angles that have one arc and two arcs. So when I come over to this one, I'm going to find that same side. And really, my figure has simply been rotated. AB is going to be congruent to side EF because they correspond. Now, the order is important. I'm going to say EF, not FE. Side BC corresponding to, well, when it has two arcs to three arcs, I come over here, it would have to correspond to side FG. Therefore, they are congruent. And we could likewise go through to find each corresponding set of sides. When you talk about your figures being congruent, you can then write a congruency statement that compares them. So when you do this, you're naming your figure. When I look at my first quadrilateral, I may name it quadrilateral ABCD. And I would say that ABCD would be congruent to quadrilateral EFGH. The order of the letters is important. So because I started with letter A here, I must start with letter E over here because they correspond. Therefore, if I had chosen to start with a different letter, maybe I chose to start with letter C for my congruency statement, that is fine. But then I would have to start my second statement with letter G. Just as a reminder, when you name your polygon, you're going to write your vertices in consecutive order. So when you pick your vertices, you have to work your way around the figure one direction or the other. You cannot jump across. So I could not name this as B, D, A, C, jumping around. We want them in consecutive order. In my congruent statement, as I said, the order is important because that order actually indicates the congruent parts. As I look down below at example A, I can see that I have some congruent triangles. My congruent triangles have three sets of congruent sides and three sets of congruent angles, and they're asking me to write a congruent statement. Now, it does not tell me which order they have to go in as far as what letter I have to start with. So that may vary. But in my case, if I chose to write my statement as triangle YXZ congruent to triangle, well, I would have to start, if I started with letter Y here, I would have to start with letter S over here. And in corresponding order, that would go SRZ. Sometimes they do not give us a picture, and so we therefore are just going to use our congruency statement. If this says that my triangle WYS is congruent to triangle MKV, and it wants to know which angle corresponds to angle Y, if I go up and I look in my statement, because Y is the middle letter here, it's going to correspond with my middle letter over there. And so it is going to correspond with angle K. Which side corresponds with WS? Well, WS is the first and last letter, so my first and last letter here would be the side MV. Because we know that congruent figures have congruent or corresponding parts that are congruent, we can use that information to solve for some missing measures. So in example B, they're going to ask us to do some solving. They have given us the fact that triangle ABC is congruent to triangle DEF. They would like us to find the value for X. So when I look at my diagram here, I see, oh, well, X is talking about my side length for AB. And sometimes it can be difficult to tell which side that would correspond with in my other triangle, because sometimes they've rotated the figure, they've reflected the figure, they've translated, or they've done a combination of those. I'm going to go over here to my congruency statement, and I see that, well, side AB would actually correspond with side DE. And so here, my side DE is going to be congruent to my side AB. So if I needed to set up and solve, I can set up 2x minus 2 equal to 6. We would solve and find 2x equals 8, or that x is equal to 4. In question B, they would like me to find the measure of angle F. So my measure of angle F, as I look here, I wasn't sure if that would be 53 degrees or if that would be the other angle. So I come over here to my congruency statement and I say, well, F and C actually correspond. So if this angle is 53 and I have a right triangle, I'm going to take 90 minus 53, and we would actually find that that angle is 37 degrees. Looking at number 2 is much the same. I'm looking to solve for some of my missing information. Triangle ABC is congruent to triangle DBC. And so here, I'm looking to solve for x. Well, in this case, because I have my 90-degree angle, I know that this also has to be 90 degrees. So I can simply take 2x minus 16 and set that equal to 90. I would find that 2x equals 106, or that x is equal to 53. My second question asked me about finding the measure of angle DBC. Well, the first thing is that we have to be able to identify that angle. Angle DBC is actually this angle right in here. If you trace it with your pencil, DBC, it will help you to find it. I noticed that in my other triangle, I have a measure of 49.3, angle A. Well, when I come over to my congruency statement, I see, well, angle A actually corresponds with angle D. And so if angle A is 49.3, this angle is 49.3. I also have my right angle, and so I know that the other ones are going to be complements of each other. I'm simply going to subtract. And we would find we would have a measure of 40.7 degrees. Lastly, we are going to work on a proof. taking a moment to look at the diagram and then taking a moment to look at what I am trying to prove. I am trying to prove that triangle ABC is congruent to triangle DEC. So in order to be congruent triangles, I know that my sides have to be congruent and my angles have to be congruent, the corresponding sides and the corresponding angles. We're going to set this up in a two-column setup, and I know that our first step is that we have to take a look at our given information. I'll then take a little bit of a shortcut here. All of this given information would come right down here into my spot for number 1. But I should read through each thing. I'm actually going to start with what they tell me is congruent. They tell me that AB is congruent to DE, and I like to double check that that is marked. And they also tell me that angle A is congruent to angle D. What else am I going to say? Well, my other part of my given information tells me that AD bisects BE. We know that bisect means cut in half. If AD bisects BE, this is the line being cut in half. So I'm actually going to go ahead and mark it like this. If I make a marking on my diagram, I need to come over here and make a statement about it. So I'm actually going to say that segment BC is going to be congruent to segment EC. What is my reason for that, or why can I say that? Well, it's because of that key word in my given, I actually have a bisector. So the reason that those are congruent is by definition of a segment bisector. In step number 3, it states that BE is bisecting segment AD. So it's actually bisecting both of those segments are being bisected. In this case, I'm going to mark it as so. I use 3 tick marks because it doesn't necessarily mean it's the same length as the others, but AC and CD are congruent, and that's exactly what I'm going to put in my step number 3. And my reasoning is actually going to be the same. It's because I have a segment bisector. Now, we're doing pretty well. We have 3 sets of sides that are proven congruent. But I only have 1 set of angles. I need to work on the other 2 sets. I've used everything in my given information, but now if I take a look at my diagram, I see there is something I can mark there. I have a pair of vertical angles. So if I make that marking in my diagram, I actually am going to go ahead and state that. Now I cannot just say angle C, because angle C is that vertex point, and there's more than one possible angle there. So I need to go ahead and say angle BCA would be congruent to angle ECD by the vertical angles theorem, or definition of vertical angles. Finally, if I have 2 angles that are congruent to 2 other angles in my other triangle, I can in fact say that angle B would have to be congruent to angle E. Why is that the case? Well, we learned last time that that would be due to the third angle theorem. Now, if you take a look at our picture, we have 3 sets of congruent sides and 3 sets of congruent angles. We have proven our triangles congruent. I can say triangle ABC would be congruent to triangle DEC. This is going to be by the definition of congruent triangles. As we look through the proof, I can show that I have 3 sets of angles, proven congruent, and 3 sets of sides. Definition of congruent triangle.